Hello. In this video, we want to go ahead and find, this is example 1C on the review for example 3. And so we're going to go ahead and find the critical numbers for f of x equals the square root of x squared plus 11. Now, to find the critical numbers, we first need to understand the domain. Now, the domain comes from wherever x squared plus 11 is greater than or equal to 0. But here's the thing. This is a positive. We're adding it, and this is always positive because anything squared is always positive. In other words, the lowest you could ever have is 0. So 0 plus 11 is 11. That's positive. So this is always positive, which means that the domain here is negative infinity to infinity. Now, another way of seeing that, if we go to the calculator, go to y equals, and say x squared plus 11. Now, on the standard window, you're not going to see anything, but if you press zoom 0, notice that we're always above the x-axis here. So let me change my window to have a minimum of 0 for the y. There you go. There's the y-axis. We're always above the y-axis, so this is always having a domain of negative infinity to infinity. Good. So, oh, yes, another way of seeing that is you can just go to the calculator. On y equals, do the square root of x squared plus 11. And when you do that, especially if you do that on the standard window, you see that it's working in, or it has stuff in both directions. Good. Now then, if we want to go ahead and find the critical numbers here, we need to find the derivative, which means let's go ahead and rewrite f of x here as parentheses x squared plus 11 close parentheses to the half power. So to find the derivative here, we need to use the chain rule with the power rule used first. So bring the 1/2 down in front. That gives me 1/2 parentheses x squared plus 11 close parentheses raised to the negative 1/2 power. That's the power rule. And then multiply by the derivative of the inside, which is 2x. Good. Now notice that 1/2 times 2, they cancel each other here. But I'm going to go ahead and bring the x squared plus 11 to the negative 1/2 to the denominator. So that's going to make this x over x squared plus 11 to the positive half power, or if you want to, you can write it as the square root instead. Either way, though, this is the derivative. Wonderful. Now that we have the derivative, we need to go ahead and find the critical numbers. And because it's a rational-esque expression here, then we need to go ahead and set the numerator and denominator separately equal to 0 here. So that means that x is equal to 0, or x squared plus 11 all to the half power is equal to 0. Now, x equals 0 is already solved. Fantastic. Over here, get rid of the half by squaring both sides, which means x squared plus 11 equals 0. Subtract the 11 means x squared equals negative 11, which means x equals plus or minus the square root of negative 11. But the square root of a negative number gives you an imaginary number overall. So what this is telling me is that this doesn't produce anything in the real numbers. And that's all we care about, are the real numbers. So this produces no solutions in the real numbers. Good. So I do have a critical number, and the only critical number then is x equals 0. And from there, we're going to create a number line. 0 is the critical number, which means we need test points to the left and the right of 0 here, and then plug these into the derivative. Now, when you plug in negative 1 into the derivative, you're going to get a negative number because it's going down from left to right there. Plug in 1 into the derivative over here. That means that it's going to give you a positive, which means it's going to go up from left to right there. Fantastic. So letter B is asking, where is the function increasing? It's increasing from 0 to infinity. C is asking where it's decreasing, and therefore it's decreasing from negative infinity to 0. And there you go. That is letter C for example, one in your exam 3 review. Have fun.